Hello students, welcome back to my channel. In today's session, we will be discussing an algorithm where we'll see how can we do partitioning an array. Alright, so let us go ahead and see the problem statement. The problem statement tells us that partition the elements of a given unordered array of n elements into two subsets so that elements less than or equal to x are in one subset and the elements greater than or x are in other subset. So what exactly is this talking about? So if at all I have to take an example, let me take 1, 4, 32, 23, 15, 12, 10. Okay, and I'll take x value as 20. So here when I talk about partitioning the array, we are not really dividing the array and displaying it, but in a given array itself, we are trying to partition it in a way. So here we will take an example of ordering the array according to greater than x and less than x. In that way, we are going to partition the array. So by the time I complete my algorithm, I should have all the values which are less than x, that is nothing but 20, should be on the left hand side, and greater than x should be on the right hand side. So that is how I'm going to partition the array into values less than x and values greater than x. So let us see how we can do that. So here is an algorithm which tells us how can we do the partitioning of array. So if you see, let me just take an example before and explain, and then we will iterate it with the value as well. So let us take an example of same thing, that is I have 1, 4, 23. Let me take here 32, 23, 15, 12, 10, 28, 35 and 38. Let me take x is equals to 20. So the logic what I will be using here is I will take a variable I which is equals to 0. Then I will take a variable j which is equals to n minus 1, which means they are pointing at the lowest value as in the lowest index and the highest index. Now I will move I towards inward as well as j inwards, comparing that the whatever the index for j I'm getting, they should be greater than x, and then whatever the index I'm getting for I, they should be less than x. Okay, so let me just give an example. For example, I will check array of I 0 whether this is greater than x. This is less, so that is fine with me because I want on the left hand side all the values which are less than x. Hence, if it is less, I'm simply going to increment the value of I. So I will not do anything here. I will increment the value of I and I will check this is also less. Hence, I will increment the value of I. But here I am encountering 32, which is of course greater than 20, and it is not satisfying my partitioning problem. Hence, I will stop it here. Now I will check about j. J I'm checking is this should be greater than x. Yes, it is greater than x. Hence, I will decrement the j value. I will compare the value. Yes, this is also greater than x. Hence, I will decrement the value. I will check this value. This is also greater than x. Hence, I will decrement the value. But this one is not greater. It is less, which is supposed to be on this side, isn't it? So now what I'm going to do, I will simply swap these two values because for I want the values less than x, and for j, I want the value greater than x. But here I've encountered opposite, hence I will simply swap these two values. So in this way, I will have 10 here and 32 over here. So 10 is going to come here and 32 is going to come here. So once I do that, I will once again increment the value and I will check. Once again, this is not less, hence I will stop incrementing I. I'll come to j and I will see that this is less than the value. Once again, I have a problem. So what I'm going to do, simply swap the values. So 12 is going to come here and 23 is going to come over here. Okay, and I will increment the value of I as well as I will decrement the value of j. Now, as and when you are decrementing and incrementing, you should always check that I value must be always less than j. All right. So in this case, when I'm checking, this value is fine for me. And also that I have come across each other. So what I will do now is I will simply stop my algorithm. And if you see, that my array is also sorted, as in not exactly sorted, but if you see that on the left hand side I have the values less than x, and on the right hand side I have the values which are greater than x, hence I have partitioned my array. So this is what is the logic what we are going to use. So let us go ahead and see the algorithm. So this is how an algorithm looks like. So let me write the values once again. So I have 1, 4, 32, 23, 15, 12, 10, 28, 35, and 38. This is my array. Okay, so this is the initial part I've done. I have read the array, I have read the number of elements, I have read the values into the array, and my array is ready to be partitioned. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equals to 10 values we have. Okay, so set an array, also partition value. So x is, let me take 20 itself. Initialize I is equal to 0 and j is equals to n minus 1. So our values are ready. Now, what is the next step? While I is less than j, remember for all the iteration, you have to check that I value should not cross the j value. Okay. Move the left and right partition closer to each other until an incorrectly positioned pair is found. Now, so what is the meaning of incorrectly positioned is nothing but if at all for I value you find a value of an array which is greater than x, and for j value if at all you find a value which is less than x, that is incorrectly positioned. Okay. So first we will check while I is less than j and a of I is less than or equal to x, do I is equal to I plus 1. This simply means that first thing is I should be less than j, as well as the value of the array should be less than or equal to x. If at all that is true, then you simply increment the value of x. So let us check. For initially I is equal to 0, yes, this is less, hence I will increment the I value. I will check for this. This is also fine for me. Hence, I will increment the I value. But here when I'm checking, what is happening is this is greater than x. Hence, I will stop. So next I will go for this while loop. So what is happening here also, I'm checking if I value is less than j, and also a of j is greater than x. For a of j value should be greater than x, then only I'm going to decrement the j value. Okay, so when I'm checking for n minus 1 value, yes, it is greater, hence I will decrement the j value. When I'm checking for this, yes, this is also greater, hence I will decrement the j value. Array of this one is also greater, hence I will decrement the value. When I'm coming here, this is not greater. Hence, I will stop it here. So once I find that, so any pairs that are incorrectly positioned, extend the partition inwards by 1, and then we are going to swap it. Okay, so I'm going to swap and then increment the values of I and j. So what I'm going to do is here, I'm going to swap the value of 10 here, and 32 is going to come here, and I is now here and j is here, incrementing I and j value because it is given here. All right, now after doing that, what is going to happen is we are going to come back to the while loop. Once again, I'm checking whether I is less than j. Yes. Once again, we are going to move the I value to inverse and j value inverse until we get the values which are not less than or greater. So for array of I value 23, when I'm checking, once again, what is happening is this is not less. So we are looking for values which are less than or equal to x. Hence, I'm going to stop the I value here. For j, when I'm checking, this is also what is happening is this is less than the value of x. Hence, I cannot move further. I will stop here. So once we do that, once again, I hope all of you are aware. This we have already discussed in the previous algorithm. This is a code for swapping any value. I'm not going to go and discuss in details. This has already been discussed in the previous algorithms. Kindly go there and check. So this is a code for swapping any two variables. So now that we have found incorrectly positioned, what I'm going to do is I'm going to simply swap them. So 12 is going to come here and 23 is going to come here, and then I'm going to increment the I value as well as j value is going to be incremented. But now when I'm coming here, what is happening is while I is less than j, but here it is not less than j. They both are in the equal position. Hence, I'm going to terminate from this while loop, and then I'm going to simply print the array value, which is nothing but 1, 4, 10, 12, 15, 23, 32, 28, 35, and 38. This is our array, which, as you can see, is on the left hand side from here to here. It is less than the value of x, and from here to here it is greater than the value of x. Hence, we have partitioned the array. So that's all the algorithm, students. I hope it is clear. It's a very simple one. If you iterate it with some other value, it will be clear. That's all in today's session, students. Thank you for watching.